Hi there, Doug from Tau Stats. It's now fall of 2024, and as a result, we're updating all of our videos describing the emission profiles inside the Bittensor ecosystem. The only constant in Bittensor is change, and there have been a lot of changes over the last few months since we last created these videos. Some of the biggest changes have been with emissions for validators, so we're going to do that video here. The biggest change for validators is the addition of child hotkeys, and the addition of child hotkeys has a large effect on the way emissions are distributed amongst the validators. As you're probably aware, the Bittensor network emits 7,200 tau a day, and that's divided amongst all of the different subnets. I'm showing X here because this number is constantly changing. On subnet 19, at the time I made this presentation, 8.03% of the daily tau was distributed to subnet 19. That's 578 tau a day. Then that's split up evenly, 18% to the owner, and then 41% to the validators and 41% to the miners. That ends up being 237 tau a day to the validators. So we'll move all of the network stuff over here to the side, and we'll just focus on subnet 19 validators. If you go to Tau Stats, you can see in the metagraph all of the validators. They have this shield is in the type, and that tells you that this is a validator. You can see how much stake each one of the validators have, and you can see their dividends. Dividends is equivalent to a percentage, the sum of all of the dividends for all of the validators adds up to 1. So 16.94 is the percentage of this 237 going to this validator. 15.32 is the percentage going to this validator. The other thing that's new in TauStat is that a validator with this yellow color is a child hotkey to parent hotkey. The orange color means that there are no parent-child relationships for that validator. We're going to go through examples of both of those as we walk through the emission distribution for validators. All right, so let's kick it off. I'm going to show 3 validators here. We've got the foundation, the OpenTensor Foundation at 16.94. They're the first on the list. TauStats at 15.32%. They're second on the list. And then I have Bittensor Guru at 5.33%, and they're the bottom one down here on this list. I can't show all of the validators. It would just take up too much space, and we're going to use these as examples, and I'll have a couple more validators as examples as we work through this video. To start off, let's work with Guru. 5.33% of 237 is 12.47 tau. Now that 12.47 tau doesn't go just to Bittensor Guru. It's split between the validator and all of the stakeholders. And the way that's decided is through a take. And the take is how much the validator receives, and the rest goes to the stakeholders. And take can be anywhere between 0 and 18%. Guru has set their take to 9%, which means that 91% go to the stakeholders, and we can do that math. 1.22 tau to the validator to support the infrastructure and the team and keeping the validator running. And then 11.35 tau is distributed amongst all of the stakeholders. When trying to determine the return to stakeholders is the nom per 1K 24 hours. So if you delegate 1,000 tau to Bittensor Guru, how much would you return? The way you calculate is you take the amount of tau emitted, divide it by the total amount of stake, and multiply by 1,000. And in this case, we get 0.036. Now, if you've looked at the validator pages on Tau Stats, you might be thinking that number is really small. It's usually 0.4 or 0.3. That's for all of the subnets. We have to do this once for every single subnet and then sum them up. And so when you're looking on the validator page, that's for every single subnet. So this is 0.036 for subnet 19 only for Guru. And so what that means is if you delegated 1,000 tau to Bittensor Guru, you'd make 0.036 tau based on the emissions just for subnet 19. The second example I'd like to show you is now Miners Union. And Miners Union, if we look on the metagraph, has 153,000 tau staked, and it is yellow, which means that there is a parent validator putting tau on the child hotkey of miners union. If we click on either the UID or the yellow amount of stake, we go to a second page inside tau stats, and it shows us that the child hotkey is the miners union validator, and that the parent hotkey is actually the OpenTensor Foundation. So to get to 153, we've got 46,000 tau from miners union and 106,000 tau from OTF. So how does that work? OTF is over here with 16.94% of the network in subnet 19, but they're also over in here. Let's walk through that. So OTF has 1.06 million stake. In subnet 19, they have made a parent hotkey, and they've put 10% of their tau on that parent hotkey and assigned it to the child hotkey of miners union. The remaining 90% is staying in on their own validator, and so their validator has about 961,000 tau on their validator. Miners union has their own tau, so if you remember, we're at 46 and 106. 106 comes from OTF's 10%, and the other 46 comes from miners union. Now remember, OTF was at 16.94%. 16.94% of that 237 is 40.1 tau. So their validator that was up at the top of the list of the metagraph is making 40.1 tau a day. Over here, miners union is making 6.11 tau a day. And between the parent and child, this is about a 70-30 split. And so we can do that math, and we can see that OTF here is making 4.277, and the miners union is at 1.833. When there's a parent and when there's a parent putting tau on the child hotkey, the child hotkey has the ability to add a take, a percentage of the parent that they can take for their own. And so we have to calculate that child take out of the parent, out of the OTF's total. In this case, miners union has added a 0% child take, so the math is really easy. We can actually just remove it for simplicity. We're going to see child take come back in a couple more examples, though. Now, before we divide the foundation's returns and miners union's returns, we need to add these up. And then we know that OTF has 18% take, and so we can figure out the amount to the validator and the amount to the stakeholders. So we add up from the parent and from the child over here, and we add them up. We can do the same thing for miners union. We know that their take, and we can figure out how much goes to the validator and how much goes to the stakeholders. So this one's a little more complicated, right? We have the OTF is running their own validator, but they're also a parent hotkey. And we need to sum everything up before we do the distribution. Because there's a 0% take here, this is equivalent to OTF having 100% here, assuming that this validator and this validator are operating at the same vtrust. And because a vtrust can lower the amount of tau that a validator makes. If we look at the nom per 1K 24 hours, it does appear that when I collected this data that perhaps the OTF validator was doing a little bit better than the miners union, because we see it's 0.034 versus 0.028. The third example is going to be tau stats. Tau stats has two parent hotkeys to their child hotkey. Let's walk through how that's going to work. So 15.32% is 36 tau. Tau stats is the child. PR validator and neural internet are the parents. And you can see they've put 42,000 stake and 24,000 tau stake, and that's 100% of the tau that they have. If you remember, OpenTensor had done 10% in that last example. We can do the math here. 92% of it, of the stake here, is from tau stats, and the remaining 7% is split between PR validator and neural. And you can see here, TauStats has a 4.5% child take. So remember, it was 0 with OTF. Now we have this 4.5% take. For the TauStats child, no effect, 33.3 tau. For PR Validator, TauStats takes 4.5% and the remaining goes with PR Validator. And the same with neural, 0.45 to TauStats and the rest is with neural. Now we can add up the amount for TauStats, PR Validator, and neural, and then we can break this up based on the take and figure out how much goes to the stakeholders and how much goes to the validator. I ran out of space on this slide, so that's not there, but we can see the nom for 1K 24 hours. And you can see that TauStats is a little bit higher because they receive a little bit from the child key take, and PR Validator and neural lose a little bit due to the child key take. You'll also notice that PR Validator is a little bit lower than neural, and that's because their take is higher. It's 18%, whereas neural's is 9%, and so that's the difference here. Okay, the last example we have here with child hotkeys and the way it affects emission is with Datura and this unnamed validator 5FE9. I'm just showing the first 4 digits of their hotkey. 5FE9 has 8.99% of the distribution, and Datura has 0.89. That's because Datura, the validator, has 531 tau stake. In subnet 19, they're putting 91% of that to this child hotkey, and they're keeping 48,000 on their own hotkey. If we look at 8.89% times 237, that's 2.12 tau. And over here, we have to split up this 8.99 between Datura and this 5FE9 that has 0 stake. So 100% of it goes to Datura. That means it is 21.3 and 0. 5FE9 has a child take of 6%. So for Datura, we have to take a 6% take here, so it goes down to 20.02, and now 5FE9 has 1.28 tau. We can add up the take for Datura from both of these, and Datura has a 0% take as a validator, so 100% of that goes to their stakeholders. Now over here at 5FE9, there are no stakeholders, so that entire 1.28 tau goes to whoever owns that hotkey. There's no reason to calculate a nom per 1K 24 hour here because the owner of this hotkey is receiving all of that. For Datura, we can find the nom 1K 24 hours 0.0416. So that's a quick walkthrough in the way validator emissions have changed in the last couple of months, especially with the addition of child hotkeys. If you're interested in learning more, subscribe to our YouTube channel. We're going to have a lot more videos coming out. Go to taustats.io where you can view all of the analytics data that we've collected on Bittensor. And you can also read our docs at docs.taustats.io. Thanks for watching.